Hello, everyone. This is the question I promise you I'm going to drop today. And also, there's one more question I'm going to drop. So, this one is from physics question on the application of Newton laws of motion. So, we are applying that law now on the two masses that is hung by the help of a pulley with the head of a string connected to the two masses. So this pulley, this string is a frictionless one. So we don't need to worry ourselves about any frictional effect. We assume that the table is smooth and there is no anything like friction. So I'm not talking about coefficient or static friction here. So let us look at the question how we can approach it when we sit in any exam. You have to be careful with the way you analyze, because if you don't analyze it well, you will not be able to solve it. Now, looking at the 6 kilogram, at the 3 kilogram, the first thing you ask yourself from a layman language that which one is bigger? Of course, you say 6 kilogram is bigger. Very, very good. Now, because 6 kilogram is bigger, that means that this system is going to shift. The direction will be towards left. So the direction of the motion will be towards the 6 kilogram, which is the left hand side. So another thing you have to take note is that we need to know because in the question I'm looking at it, the tension. So when we are considering 6 kilogram, we consider the forward tension. When you are considering 3 kilogram, you consider the backward tension. That is the way, the principle. Because 6 kilogram is bigger, you consider the forward tension. Then for the 3 kilogram, you consider the what? The backward tension. Now, good. So we are going to solve it now. So from Newton's second law, you have that F is equals to ma. This is the fundamental Newton's second law. It's very fundamental. Or when you look at this, the terms of this pulley, you are having two masses. That means that something will come to your mind, which is net force. So using this second law, so we are going, because of this system, is a system of two masses. So we are going to talk about net force. Then when you tell net force, then something will tell you about total. That is total mass. Empty total mass times what? Acceleration. Do you see it now? So having solved that, then let us look at how we find our acceleration. So acceleration will now be net force over total mass. Now, how do we find our net force? Now, net force is the weight force in each of the object. What do I mean by weight force? The weight force is the what? Is the force of gravity on each of the masses. Now, the force of gravity here is what? Is on the 6 kilogram is 6g minus the force of gravity on the 3 kilogram is what? Is 3g over total mass 6 plus 3. That is 6 plus 3. Everything what? In kg. Or one weight first. I know what you are thinking. The 6 kilogram is on the horizontal table. Therefore, on the horizontal table, here G is equals to 0. So here we'll mark it to be what? Is 0. So if this is 0, it will now become acceleration equals to 0 minus 3g over 6 plus 3, 9. So what is 3g? If you take g to be what? 10 meters per second square. So you are going to have minus 3 times 10 over 9. Do you see it now? So acceleration will now be equals to 3 here 1, 3 here 3. So that will equals to minus 10 over 3 meter per second square. In physics, once you don't put your unit, is if you fail the exam, you fail it, because the unit shows the what you are really solving. Is it which quantity you are actually solving? So we are solving for the acceleration time what minus 10 over. Why minus? The reason for the minus is because the acceleration is actually going towards the left, going towards the what? The left direction. You get what I'm saying now? It's going towards the left direction. And it's also showing that there is a reduction. There is a reduction because of the motion. Trying to pull this one upward. The force of gravity is acting against the motion. That's why you have what? Negative. The force of gravity is acting against the motion. So let's go for the tension now. Let's go for the tension. Now the tension for 3 kg, because it's going upward now, because it's going to upward, there's a gravity 3g acting on the mass. Force of gravity is acting on the mass, and the one that is causing it to move, which is 3a. The one that is causing it to move is this. The one that is causing it to that is acting on it, the weight force, the force of gravity acting on 3 kg is what? 3g. So since it's moving upward, so we are going to have T equals to 3g because it's moving upward. So you require a what? An addition, an added motion. You get to be able to move freely. To be able to move freely. So a tension is needed, which is what? You need more tension. When it's moving upward, you need more tension. So that will be 3g plus 3a. So let's go back calculate it. We have T is equal to 3 times 10, that is 30, plus 3 times, acceleration is minus 10 over 3. You have minus 10 over 3. So you have 3 here 1, 3 here 1. So you have T equals to what? 30 plus times minus, that is minus 30 minus 10. That is equals to what? 20 Newton. 20 Newton. Let's calculate the one for T here also. The tension forward. Tension forward. Now, because of it is actually pulling it to himself. So since is greater, so it doesn't require more. It doesn't require so much tension. So you just have. So you have 6g minus 6a. But you know I told you that g is 0. There's no, so since g is 0, so you have t equals to minus 6a. So what is the acceleration? So you have minus 6 times minus 10 over 3. So you have 3 here 1, 3 here 2. Minus times minus 2 times 10, that is 20. That is 20 Newton. So we have the same tension. Why do we have the same tension? Because of it is one pulley. You see? Just one pulley. Require it to what? To require it. One pulley required. Assuming you have another pulley here, you have gotten different tension. So you have T is equal to 20, T is equal to 20, showing to us that our answer is actually correct. So that is it. Anytime you see a question like this in exam, just go for it. Use this method, analyze your problem, and you will get the answer. So bye-bye. We'll see you again.